Welcome back. In this section, we'll be talking about synthetic division, which is an easier way for us to divide one polynomial by another. This is something that you may not have seen before, so this part might be new to you. It is a very good technique to have. We're going to look at dividing polynomials using long division, which you may have seen, and if you have seen it before, you'll remember that it's not always the nicest thing to do. But synthetic division is a faster and easier way for us to do this. And you'll see later on in the course that being able to divide polynomials will be very important. In fact, we'll be spending some time factoring polynomials and doing some division to make the factoring happen. So first off, just to remind ourselves some definitions of things, the number that you're dividing into, or the thing that you're dividing into, that's the dividend. The thing that you're dividing by, that's the divisor. So when I say, for example, 100 divided by 4, 100, that's the dividend, and 4, that's the divisor. And of course, the quotient, that's how many times that number goes in. So 4 goes into 100 25 times, so 25, that would be the quotient. Now, if you have a remainder, then as it turns out that this fraction of the dividend divided by whatever the divisor is could be written as your quotient plus your remainder over whatever you were dividing by. This is something that you might not necessarily remember in words, but you should remember it from back in the day when you were in elementary school, going back and forth between a mixed number and an improper fraction. You might not have actually thought about it as a division sort of a story, but something like the fractions 37/4, it is the same thing as the number 9 1/4. And the reason why they're the same as each other is that if you were to take 37 and divide it by 4, it goes in 9 times and it has a remainder of 1. So you could say that 37 divided by 4 is the quotient, 9, plus the remainder of 1 over the divisor, which is 4, or 9 1/4. And that's sort of the whole reason of the procedure of how we won't go from an improper fraction to a mixed number. Now, like I say, this is true whether we're talking about dividing numbers by numbers or whether we're talking about dividing polynomials by polynomials. So if you've got two polynomials and you've divided one by another, you can make a similar sort of statement. You can say the one polynomial divided by the other is equal to this quotient plus whatever the remainder is over whatever we're dividing by. Now we're going to have a little bit of a reminder here about how long division works. We're going to do long division with numbers first, and then we'll do polynomials after. So here I'm dividing 4 into 770. And remember that when we're dividing with long division, the idea is we ask ourselves, how many times does the divisor go in? So in this case, how many times does 4 go into 7? And the answer is it goes in once. The next thing that we do when we divide is we then would multiply. What is 1 times 4? The answer is 4. We subtract, and then we bring down the next term, or the next digit. So that's our idea for long division. 4 went into 7 once. 1 times 4 was 4. 7 minus 4 gave us 3. We bring down the 7, and then we just repeat the process. This time we'll ask ourselves, how many times does 4 go into 37? And it goes in 9 times. We know that 9 times 4 is 36. Subtract. And we bring down again. So how many times does 4 go into 10? It goes in twice. 2 times 4 is 8. We subtract. There's nothing left to bring down, which means that we are finished. We have that our quotient is 192, and that our remainder is that last amount that's left over, that amount of 2. So if we wanted to use what we said on the previous slide, we could say that 770 divided by 4 is our quotient plus our remainder over our divisor, or 192.5. Now the idea is similar when we're dividing with polynomials. So first off, I'm going to take my dividend, x cubed. I'm going to give myself a little bit more room. There we go. X cubed plus 2x squared plus x plus 1. And I'm going to divide by x minus 3. So I'm going to do the same sort of thing. On the previous slide, just a reminder, we asked ourselves things like, how many times does 4 go into this number? We figured out how many times it went in. We then multiplied those two numbers together. We then subtracted, and then once we subtracted, we brought down the next digit. The same sort of thing is going to go on here. Now, one thing to make our lives easier would be this. We're going to ask ourselves, how many times does x minus 3 go into this polynomial? But that's kind of a difficult question. If you wanted to know how many times does x minus 3 go into the first term, maybe not the easiest question to answer, so we'll ask ourselves the easier question of how many times does x go into x cubed, into that first term. And that one we can answer. X into x cubed divided by x is x squared. And now we'll multiply. So when we multiply, we'll be multiplying x squared by this polynomial x minus 3. So when I multiply them together, x squared times x minus 3, that would be x cubed minus 3x squared. And so just like we did before, after we multiplied, the next thing that we did was to subtract. Now, when I subtract, I'm going to put brackets around that polynomial because I want to make sure that I'm subtracting the whole thing. If I don't put brackets around it, I will probably not subtract negative 3x. I'll probably wind up adding negative 3x, which is not what I want to do. I want to make sure that every term is being subtracted. X cubed minus x cubed, that's gone. 2x squared minus negative 3x squared, that's 5x squared, positive. And now we bring down the next term, which is the plus x, and we continue and do the same thing again. So we'd ask ourselves, how many times does x go into 5x squared? And the answer to that would go in 5x times. Then we'll do the same thing that we did before, taking 5x and multiplying by x minus 3. So 5x times x minus 3, 5x times x is 5x squared, minus 3 times 5x is negative 15x. And now we're going to subtract. 5x squared minus 5x squared is gone. X minus negative 15x is the same thing as x plus 15x, or 16x. Bring down the next term, the plus 1. Continue the process. How many times does x go into 16x? It goes in 16 times. We multiply. 16 times x is 16x. 16 times negative 3 is negative 48. And now we'll subtract. 16x minus 16x, that's gone. 1 minus negative 48, that is 49. And since there's nothing left to bring down, then we are finished. That means that our quotient should be x squared plus 5x plus 16, and that our remainder should be 49. And if we wanted to, we could do the same sort of thing that we did before, where we could say that x squared plus 2x plus 1 plus x, that first polynomial divided by x minus 3, that it's equal to our quotient plus our remainder over our divisor, if we wanted to say such things. So I'm just going to make that a little bit smaller so that I can fit that all in. So I could say, if I wanted to, that x cubed plus 2x squared plus x plus 1 divided by x minus 3 is our quotient, plus the remainder over our divisor. So there we go. We found our quotient and our remainder using long division. Now, this was a lot of work, and there's a couple of places where people tend to make mistakes. The one mistake that people tend to make is usually involved here in these stages where we're doing our subtraction. That's usually the place where people make a mistake, losing a negative somewhere along the way. And of course, like everything that's built on smaller steps being put together, if I make a mistake here in the first stage and get this little subtraction done incorrectly, then everything that will follow won't be correct either. So we want to make ourselves have a little bit less work to do, number one, and we also want to make it a little bit less error prone. One thing that you'll probably be noticing here is that these x's are really only helping to line things up. We have the x cubes all lined up, the x squares all lined up, the x's all lined up, the constants all lined up. But that's really the only thing that the x's are doing for us. For the most part, we're just using the coefficients. And that's kind of the idea behind synthetic division. With synthetic division, we're going to be dividing, but we're going to leave out all of the x's. We're going to just focus only on the coefficients themselves. Now, synthetic division can only really be used when you're talking about a divisor that's either x plus a number or x minus a number. So for the problem that we had before, using division with dividing by x minus 3, synthetic division will work for such a problem. Now, first thing that we'll do is take our dividend, and we're going to write out all of our coefficients in order from all the terms. We have 1x cubed, 2x squared, 1x plus 1. And if there were any missing terms, any powers of x that were missing, you would have to put in a 0. So here we have constants, x's, x squareds, x cubes. There are no terms that are missing, so there we go. We have our coefficients. And now the little twist that we have here, this is to make us not have to do subtraction. Rather than using x minus 3, since the number here is minus 3, we'll use the opposite of that and use plus 3. And so what that's going to do for us is that instead of us having to subtract all the time, instead we'll be adding. We're going to be doing the opposite. And we know from experience that adding is a lot easier than subtracting and less error prone. And that's kind of the nice thing about synthetic division. The first step for synthetic division is always to take that first coefficient and bring it down. So there we go. I have brought my first coefficient down. And then from that point on, it's just multiplication and then addition. Each time we'll be multiplying, in this case, 3 times 1, that is 3. And then we add. 2 plus 3 is 5. We'll multiply 3 times 5. 3 times 5 is 15. We'll add 1 plus 15, that's 16. We'll multiply 3 times 16, that's 48. We add 1 plus 48, that's 49. Now, when we've got to the very end, the last number that you'll have here, this will be your remainder. So here the remainder is 49. And what's given to you to the left of this, these are the coefficients for your quotient, for the constant term, then the x term, and then the x squared term. So if we were to say what those coefficients tell us, they tell us that the quotient would be 16, 5x, and 1x squared, or in other words, x squared plus 5x plus 16. And we can confirm that that's exactly the same answer that we found from the previous work, but notice how much less writing I had to do, and also notice how much faster it was. Also a little bit easier, because again, instead of multiplying and then subtracting and then multiplying and then subtracting, here we're multiplying and then adding and then multiplying and then adding. The only thing that we need to remember is number one, make sure that our powers are written from smallest to largest, and that if we have any missing powers, we include zeros as appropriate. And number two, whatever this number is, if it's x minus whatever, then we'll use the positive version. If we'd been dividing by x plus 3, we would have used a negative 3 instead. And that's basically it for synthetic division. We're going to do some more examples now. So here I want to find quotient and remainder when I'm taking that fifth degree polynomial and dividing it by x plus 2. My polynomial is already in order from largest to power to smallest. I'm going to write out all the coefficients. We have 1x to the 5. There are no x to the 4s. There is 3x cubed. There are no x squares. There's minus 1x. And there's plus 1. So I've got all of my coefficients. And as I said, for any missing powers of x's, the coefficient is 0. There are 0x to the 4s and there are 0x squareds. So I have 1, 0, 3, 0, negative 1, and 1. Those are all of my coefficients. I'm dividing by x plus 2, so I'm going to use the opposite of plus 2. I'll use negative 2. And the first move is always to bring down. And then from that point on, it's just multiplying, then adding. Negative 2 times 1. 0 and negative 2 add up to negative 2. Negative 2 times negative 2 is 4. 3 plus 4 is 7. Negative 2 times 7, that's negative 14. 0 plus negative 14 is negative 14. Negative 2 times negative 14 is positive 28. Negative 1 plus 28, that is 27. Negative 2 times 27, that is negative 54. 1 plus negative 54, that is negative 53. And as before, the last number that we get, that would be our quotient. Our quotient is negative 53. And that for all the other coefficients that we have here, those are for our quotient. Or rather, I said quotient was negative 53. I should have said remainder, rather, is negative 53. Wasn't thinking, was writing. Sometimes writing and speaking at the same time doesn't quite work out the way that we'd like it to. Sorry about that. So for what's remaining, we have here, these are all coefficients of our quotient. And these are always in the order from the constant term to the x term to the x squared, x cubed, and so on, in increasing order. So these are all coefficients for our polynomial, for our quotient, written in increasing order. So we have constant x, x squared, x cubed, x to the 4. So what we'll get as our quotient, it's a polynomial where x to the 4 is the highest power of x. X to the 4 minus 2x cubed plus 7x squared minus 14x plus 27. Now, nice little thing, and this is sort of the why we're going to be thinking about dividing. If things divide evenly, then you have found a factor. So for example, we know that 4 divides into 36 evenly, that it goes in 9 times with a remainder of 0. In other words, if you've got a remainder of 0 when you divide, you have found a factor. 4 is a factor of 36 because it goes in and leaves a remainder of 0. Now the same thing is true for polynomials. If a polynomial goes in and leaves a remainder of 0, then it is a factor. So when the question is, can we find out, is x plus 3 a factor of this polynomial, yes or no, we can ask just by using synthetic division. If the remainder is 0, then the answer is yes. If the remainder is not 0, then the answer is no. So for this polynomial, it's 1x cubed plus 3x squared plus 4x plus 12, and we're interested in checking if x plus 3 is a factor, so we'll use -3. We begin by bringing down, we multiply, we add. We multiply, we add, we multiply, we add, and here the remainder is 0. So the answer is yes, it is a factor, and in particular you can say that that polynomial x cubed plus 3x squared plus 4x plus 12 could be factored out now as x plus 3, which we know that that was the factor, multiplied by whatever our quotient is. And our quotient would be constant x squared. Our quotient would be x squared plus 0x plus 4. So we've been able to confirm here that yes, x plus 3 is a factor, and once you factor it out, it leaves x squared plus 4 behind. Let's check the next one. We have x cubed plus 2x squared plus 1x and -3, and we want to check to see whether x minus 1 is a factor, so I'll use +1. Bring down, multiply, add. Multiply, add, multiply, add. And if we're looking at the remainder here, the remainder is 1. So the answer, is x minus 1 a factor? No. X minus 1 is not a factor.